Hi guys, in today's video I want to talk a little bit about basics with multimeters and which one would be interesting to have for you if you start building battery packs. You know, multimeters, they come in many different brands. They come in different accuracy classes. They come with automatic range, manual range. They come in different price classes where all of this is playing into a little bit. But one aspect which I find interesting in our case is the count. So count, what does count mean? Every multimeter comes with a LCD display. So every multimeter, let's say the entry class and the mid class, they usually have a 4-digit LCD. Then maybe professional multimeters, they can also come with 5 digits, and then you of course have the laboratory equipment. They may have 10 or more, but what you will buy somewhere typically will have 4 digits, and the count now means what is the maximum number that display can show. And if the meter is now a 2000 count meter, for example, then you will see a 2 followed by 3 zeros at the maximum count. What classes of counts do we have? The beginner level is 2000, then you have 4000 counts, then 6000 typically, and then it will also have a 9999 at the best, of course, with 4 digits. But the count does not necessarily say something if the meter is expensive or cheap or not accurate or whatever. It is just one attribute a meter can have. So I have 3 meters here. This is a 2000 automatic range, 2000 manual range, and 6000 automatic range. This is my most expensive, $50. This one I paid $20 10 years ago, so it will be also more expensive now probably. And this one is an online store meter. I bought it for $15. So it's the cheapest, but it has the highest count of 6000. When we are talking about building battery packs, we want to measure on cell level. This here, lithium polymer. This here, lithium iron phosphate. I assume that everybody who is building batteries today will use lithium ion batteries of any kind. And then we also measure on the pack level. Pack level, of course, now depends what sort of pack maximum voltage somebody is building. You have the 12 volt nominal systems, you have 24 volts, 48 volts, and that will then probably it already for us DIY battery builders. Okay, so my test setup is we will just go through all the voltage ranges which are interesting for us and show what each of these meters will present on its display. Okay, let's do that now, and then we have a quick debrief later. Here's my test setup. I have my DC power supply, and it is supplying here this terminal bar, and on each terminal, plus minus, I have my probes to each individual meter. And so this setup we are going to use, and I will then show you how each meter is showing its values on the display and when it has to switch to the next range, so that way we can see how this is best usable and suitable for your battery build. Let me show you what I have here. So my first meter, this is a Unity meter. It has a current clamp on it. It is a 2000 count automatic range meter, and it is the most expensive of these 3 here. It costs around $50 US. So the next one, this is my oldest meter here on the table. I bought it once in a construction market in United States, a Southwire. Manual ranges, so you have to switch your ranges by yourself. This one also a 2000 count meter, and this one, my latest addition, it's a no-name online store multimeter. Zoe, it's called here. You can buy these under different brands in every online store everywhere on the world. Automatic range, but 6,000 counts. So now we are going to see how these meters will behave when we are changing the voltage here. I have set 1 volt on my power supply at the moment. So you can see each of these meters is showing around 1 volt. You also can see, let's raise it a little bit higher. We have 4 digits on each of these meters, and the manual range meter, it does not even show us a decimal point because we have to look what we have selected on the dial there. So but this one 1.008, so 1000 millivolts, and 1.013 volts on the other one. So 1 volt, that is in the range of a AA, AAA battery. Let's raise this up. We are going to territory of lithium iron phosphate. Maximum voltage on that one is 3.8 volts. So let's raise the voltage, and now you can see we have 2 volts now passed. Our automatic range meter is still showing more than its counts actually, but the manual range meter already showing over limit here. So we have to select the next higher range. Now we have 2 digits in the front. The first one we cannot see, and then a decimal and only 2 digits behind the decimal there. So here still 3 behind the decimal. Let's raise it higher, and now it's switched over. So you saw around 2.2 volts, it switched into its next range, and now we have lost 1 digit behind the decimal here, so 2.37 there. Our 6,000 count meter is still showing 2.3902. We still have 3 digits behind the decimal, and that continues. So we are coming now into the range of the lithium iron phosphate, maximum voltage 3.65, and yeah, you can see 3.6562, and here nicely still 3 digits behind the decimal. Okay, our next territory is lithium, standard chemistry, NCA, NMC, lithium polymer. The maximum voltage there is about 4.25. So we are going into that area, yeah, as expected. 4.1214, 2 digits behind the decimal, and our 6,000 count still showing 3 digits. And this would be now where the 4,000 count meter would also switch into its next range, and we would lose 3rd digit behind the decimal. But the 6,000 perfectly showing. So we can continue ramping up. Now we are coming also already to peak voltages. First peak voltage, if you are building a 12 volt battery pack, we can have up to somewhere 13.8 volts. But this would be the highest peak voltage on a 12 volt system. Well, everywhere we have now only 2 digits behind the decimal, so they are showing similar in this area. So now for those who are building 24 volt packs, maximum voltage there around 28 volts. We will not be able to go that high with this power supply, but you saw here already The manual range meter has already left again its selected range. We are above 20 volts. So we have to go to the next range up there. And yeah, now we have lost the next digit behind the decimal again. So only this one also, it already automatically switched over. We only have one digit behind the decimal left. But our 6000 count, this would also be valid for the 4000 count meter. We can see 2 behind the decimal. This is now where the range of the power supply is ended. Maximum voltage is reached. And you can see this nicely now on the 3 meters. So only our 6000 count, and if you would have a 4000 count, are showing 2 digits behind the decimal. Okay, so here we now at the battery pack. We have a lithium iron phosphate pack and 48 volts nominal. If we look at the cell level, the pack is discharged now. We can see 3.214, so 1 digit, decimal, and 3 digits behind the decimal. And if I clip this on now on pack level, then we can see 51.81, so we have digits behind the decimal. Very nice. Why do we want 3 digits behind the decimal on cell level? Lithium iron phosphate cells especially, they have an extremely flat charge and discharge curve. So if you only have 2 digits behind the decimal, you will not see any changes for long stretches during charging and discharging. And for that, 3 digits are very convenient. That was it already in today's video. You see, when you are going for the 48 volts packs with any of the lithium ion battery types, you want to have at least a 6000 count meter, because this will give you a nice display until the maximum voltages you have. Yeah, and the rest, you know, if you want a highly accurate, if you want a branded meter, etc., that's your decision. You just check up on your market what you want to get. This was just one aspect of metering. So thank you for watching this video. Please leave a comment on the down. What is your favorite meter? Is it an expensive one? What can it do? Like the video, subscribe to the channel, and I see you next time.